3D, index numbers, the CPI, and beyond. Here, let's introduce the idea of the index numbers. Index numbers are really the same thing as percentages, but we don't write the percentage sign. And instead, we just write the number down, and we use a certain value as reference. So you'll notice the way we calculate index number is very similar to calculate percentages, but I don't need to leave a percentage sign as my answer at the end. You'll notice if we use the price 1.22 in 1980 as our reference number, then what we can do is we can find the percentage. Okay, we can find the percentage with respect to the 1.22 in 1980. For example, to find that it's 0.36, the price of 0.36 is 29.5%. What we do is we sort of simply do 0.36, right? And we divide it by 1.22. And we change our number, we change our answer at the end to the percentage form. So this would be roughly 0.295, and we can multiply by 100 to get to 29.5%. When we do the when I do the index number, all we're saying is that instead of 100%, we call this 100. And all the other numbers are exactly the same as percentages, but without the percentage sign. And we call these number index numbers. Index numbers are useful when we compare values that can be widely different. So for example, if we think about a detached house in Coquitlam, say a few years ago versus like many years ago. If we use this as a reference value, so if we call this 100, we can find out how much more that is. And we simply follow the formula. We take our new value, divide it by the original value, and then we multiply by 100, just like we would if we were trying to find the percentage. Here, when I divide, I get 2.597. I multiply by 100, I get 259.7. And so something like this tells you, if I spend $100 in 2005 to buy a house, I will need $259 to buy the same house in 2020. If I spent 100 million, I will need to spend 259.7 million in 2020. Now, it's just so happened that this price index that we have calculated over here is what the real estate board, what the agents use to tell us that the price of the home always goes up. And what we can do is we can use the same price index. We can use the same index number. And we can use the index number to find out how does our home appreciate in value. So let's say in 2015, we bought the house for $800,000. How much more would it be in 2020? How much would it be worth later on? Now we know 172.7 back in 2015 will grow to 259.7. So what we'll do is this. We can divide them. It's a little bit like doing unit conversion, right? Doing unit conversion, we take 2015 and then we look at what happens in 2020. And what we're going to do is we're going to take our price in 2015, right? We're going to take our price in 2015. So essentially, I'm taking 800,000, right? 800,000. And we're taking 800,000 multiplied by the difference in the index number. Now, the 800,000 is from 2015. So I put 2015 in the denominator. I put the new year, the newer year, in the numerator that we're trying to get to, just like doing unit conversion. In this case, we do the ratio first. We find the difference first. This tells me that the price in 2020 is about 1.5 times bigger, more expensive. So I can just simply multiply 800,000 by 1.5, and that gives me the price of 1.2 million. And this tells us the house is used to worth the house we bought in 2015 for 800,000. It should be worth a little bit more in 2020, $1.2 million. Now, when we pick a particular value to be our reference value, that actually have no consequence at all, right? It doesn't really matter that I decided to pick 1980 as my reference value. I can pick something else. It doesn't matter which one I use the reference value as. So for example, I can redo everything with the year 2000 with 1.56 as my reference value. So then the 0.36 over here, I will take 0.36 divided by 1.56, and that gives me 23.1. So my price, my index number over here is now 23.1. And I can do that for all the different numbers. But what you'll notice is that the index number are there to tell us how does the number change, right? How does the number change? So if I compare, say, 29.5 and 232.8, let's say if I try to compare, if we use our calculator, then we can see that if I do 232.8 and I divide it by 29.5, this gives me 7.89, right? The price increased 7.89 times, right? The price got 7.89 times bigger. But if I look at a different set of reference value over here, and if I try to do the calculation again, we should get the same number, 182.1 divided by 23.1. That's still roughly 7.88, 7.89 times bigger. So all reference value tells us is how does the price change throughout the years. And the actual value here doesn't matter. It's the relative difference or the change that's more important for us. Now we know as price increases, this is called inflation. So one of the important price index number that we use is called the consumer price index. And the consumer price index, the CPI, is the index number calculated by finding out the cost of a whole bunch of goods and services, including food, including transportation costs, including living costs, including the cost to buy, say, a shirt to wear, that kind of thing. And you can see that the consumer price index has gradually increased over time. Things has gotten more and more expensive over time. And so we can use the CPI to calculate how, say, $3,000 back in 2000, how that would translate in 2020, how that would compare in terms of 2020 money. So we will do the same thing, right? We do it like a unit conversion. Since we start with $3,000 in 2000, I want to take my $3,000. I want to divide by the CPI in year 2000. Right? This is 3,000 is in the year 2000. I divide it by the year 2000, and then I multiply by the year that I want to change it to. So in this case, we take our 3,000, we divide it by 93.5, we multiply by 136.8. You can do them separately here, or you can do them together, or you can do them together like so. You can do 3,000 times 136.8 divided by 93.5. Personally, I like doing it this way better because this is how we do unit conversion. Right? We take year 2000 divided by year 2000 multiplied by year 2020. And this will give you the same answer as 4,389. So what that means is that 20 years ago, when it's $3,000, I can buy something for $3,000. It's going to cost us a little bit more now. It's going to cost us 4,389 20 years later. The inflation rate is then how these price indexes are changing, how the money is changing. So what we're going to do is we're going to calculate the relative change between one year and another. And how do we calculate relative change? Well, we can do it two ways. We could do it like the example show over here, like the solution show over here. But I like to do it similar to relative change. And in relative change, this is what we do. We do 136.8 minus 133.6, right? We went up. We went up by 3.2. But 3.2 is not our answer. We have to divide it by what we started with, right? What we're comparing it to. We're comparing the 3.2 to what we start with, 133.6. And the advantage of this is if you put it into your calculator, you'll get something roughly equal to 0.024 or 2.4% higher if I multiply by 100. And this is, for me, easier to understand because we're finding the difference. We're finding how much more, and I'm finding out, what's the percentage of that. Rather than just dividing it, and then we have to subtract 1. So both ways are okay, but I like this way better. When we adjust the price for inflation, this ties into what we were talking about before. We do this a little bit like doing unit conversion. We look at the years. So if I want to change to a different year, I take my price, I divide it by the current year, and I multiply by the CPI in a different year. So for example, if we want to compare the salary of 2 star players for the Vancouver Canucks, now you'll notice back then in 2010, they were making 6.1 million. And in 2017, they were making 7. Well, it seems like 7 is more. But is it really more? Because we know everything will be costing more in 2017. So what we can do is we can convert the price, convert the salary of 6.1 million, and we can change that to the year 2017 to see how much is it in terms of 2017 dollars. So remember the 6.1 million is from 2010. So I will put 6.1 million here, and I will put the CPI from 2010 in the denominator. In the numerator, I put the CPI for the year that I want to change it to, 2017. Put everything in the calculator, and that's 7.22 million. So in fact, they were making a little bit more back then than they were in 2017. Right? It's just that 2017, there was inflation, so number all got bigger. So what you'll notice is that if I look at historical data for cost of anything, like cost of gasoline in this case, this is the cost of gasoline in the United States. So it's the price in US dollar per gallon. Now, throughout the years, the price is going to go up because there's inflation. But what you'll notice is that if I adjust for inflation, if I take each of these dots and do the calculation that we were doing before, I can change the price in terms of 2012 dollars. Now, remember, this year doesn't really matter. This is just our reference value. And what you'll notice is that once I change the price, once I adjust for inflation, it's easier to see that the gasoline got more expensive, in the early 80s and in the late 2000s. And what you'll notice that there's a big dip here. That's the financial crisis. So people, it's a recession and people don't drive as much. And this allows us, after adjusting for inflation, this allows us to compare whether the price has actually gone up or has gone down.